Hi everybody, this is the last geometric relationship page, so let's jump into it. So this is just like the previous 9, 17, or whatever, how many videos. We're doing the same type of thing, identifying relationships, setting up an equation, solving it. Now, all these were kind of inconsistent on the quiz. And so hopefully if you're watching this video and you're working through this, you're picking up that it kind of falls into 1 of 6 categories. The bottom half is all going to be the same thing. Up here, it's always really been 3 things: linear pair, supplementary, it's been complementary, or vertical. And I don't think we're going to see any kind of different things going on. So first things first, let's identify. So we have angle 1 and angle 4. So I'm just going to try to highlight it here, kind of in this pinkish color. So angle 1 and angle 4 are crossing each other. They do share common vertice, and so we're going to call those vertical angles. Okay, vertical angles by rule are congruent, and so we should have the measurement of angle 1 should be equal to the measurement of angle 4. You can also write that as a congruent statement, but since it's asking for like an equation, that's how we should represent it. Number 2, 7, 8, 9. Well, 7, 8, and 9 I call all in a row. And I'm not going to individually highlight them, but we should know when they're all sharing this common vertice and they're adjacent, they form a line, and that's the important feature to see. Lines are always going to be linear pairs in this fashion, and linear pairs have to also be paired with the idea of supplementary. Okay. One automatically gives you the other. In the same way vertical angles are always congruent, linear pairs will always be supplementary. By rule, supplementary means they add to 180 degrees, and so this is going to be a tight squeeze here, but we have the measurement of 7 plus a measurement of 8 plus a measurement of 9 equals 180 degrees. So let's kind of overwrite that text there. But it's going to be adding together to make 180 degrees. Right. Last one, 5 and 6. Well, if we look at 5 and 6, those also form a line. And so even though it's only 2 angles as opposed to the 3, this is also still linear pairs. And linear pairs by rule are also always, supplementary. Okay, which means we're going to recycle the same equation. We're going to add together to make 180 degrees. In this case, the measurement of angle 5 plus the measurement of angle 6 equals 180 degrees. Now, I think we mentioned in one of our previous videos that this kind of geometric relationship work is going to comprise at least 50% of your test. I mean, it's at least 50, if not probably a touch more. So we haven't sat down and done a final calculation yet, but it's going to be roughly 50% of your exam. All right, so in the bottom section, we are now kind of looking for a relationship, but because of how they're grouped, we can kind of assume they're all more or less the same one, but hopefully we recognize it right away. If we have an intersection of 2 lines sharing a common vertice with angles opposite each other, that is always going to be vertical angles. Okay, so that's going to be the answer to the first question. The answer to the second question is an equation. Well, by rule, vertical angles are congruent. It's always have 2 things equal to one another. Congruency means equal. In this particular case, the 2 angles, 3x plus 10 and 2x plus 15. Okay. Now, once you get to this point, you more or less won the problem. So it's just algebra and substitution from here. So in solving algebra, let's subtract the 2x from both sides. I'm going to do both steps at once. So the x's are on the left, which means we have to clear off this 10. So we'll subtract 10 on both sides. Okay, 3x take away 2 x's, leaves a single x. Okay, the 10's cancel. We have 15 minus 10. That'll give me an x value of 5. Third step, we need to resubstitute and find angle values. So that's just an issue of going back into the original diagram, noticing the left-hand equation, left-hand angle, is 3x plus 10. So that turns into 3 times 5 plus 10. So that's 15 plus 10, which I believe is 25. I can do a mental math this morning. Okay, then we have 2 times x plus 15. That's 2 times 5, 10 plus 15, also 25 degrees. Now this is, of course, no surprise. Vertical angles by rule are congruent, which means they're equal. So if we've gotten different angle values, that means something went horribly wrong, and we have to fix it. Okay, so let's continue. So this one is going to be vertical angles again. Okay, Now it's easy to go in automatic mode, but checking the structure, we do have a common vertice, we do have angles across from one another, ergo these are definitely vertical. Vertical angles are always congruent, and so we're going to have 3x equal to 2x plus 16. Okay. In solving, this one's much simpler. We're just going to subtract 2x from both sides. 3x's take away 2x's leaves us an x. Cancel on the right, I'm going to equal 16. Okay. Final step in substitution. We have 3 times 16. There's Mr. Calculator. Okay, so 3 times 16, which gives us 48. Okay. And we check on the right, we have 2 times x plus 16, so 2 times 16 plus 16, also going to be 48. Okay, and you should note that I know you can't see me do it, but I'm legitimately checking those in the calculator. I'm still running it through. Even after like 400 years of studying mathematics, I'm still going to do that substitution because I want to know I was correct with my equation solving. All right, number 3. Okay, again, classic intersection, point in the middle, angles across from each other, not next to each other, non-adjacent as we say in the game. So this is again going to be vertical angles. Okay. So we have to set up an equation. Vertical angles by rule are always congruent. So the equation we're looking for is 4x minus 26 is the same as 3x plus 4 because again, of course, congruent means the same. In algebra solving, we'll subtract 3x on both sides. So we have x minus 26 is the same as 4. Then adding 26 on both sides yields a result of x being 30. Okay, in our check step. Okay, so we have 4 times x minus 26 for the top angle. So that'd be 4 times 30 minus 26, negative 94 degrees. Okay, so we know we're good as long as the bottom angle turns out that way. So we have 3 times 30 plus 4. And lo and behold, that's 94 degrees as well. Okay? Please don't forget that last step. Several people did on the last quiz, and that cost them gravely. So please don't be that person. Okay, so bottom set of problems here. Let's choose a new color. Orange. All right. Intersection, shared vertice, angles are crossing each other, classic vertical angles. Okay. Vertical angles by rule are congruent, and so we'll have 7x plus 17, same as 8x plus 2. Okay. In solving, let's move our x's to one side. So we have 17 is the same as x plus 2. Okay, so we move our 2 over, and we end up with x is the same as 15. In checking, we have 7 times, we have 7 times x plus 17, so that's 7 times 15 plus 17. Here is 122 degrees. Nice 2's angle, so 8 times 15 plus 2, also 122 degrees. That's going to celebrate, we got the right answer. All right. Read again. Okay. Intersection, shared middle, opposite angles, so that's vertical angles. Vertical angles by rule, still congruent, so x plus 16, the same as 4x minus 5. Let's solve it. Subtract our x. And at the same time, x's are on the right, so we can add 5 to move our numbers to the left. And so we have x's gone on this side, 16 plus 5 is 21. 5's are gone on the right. 4 x's take away an x, make 3 x's. So 3 x's make 21. Although we can predict it, that would be the step, is to divide out. And so we have x is equal to 7. All right. Angle findings, so x plus 16 turns to 7 plus 16, for a total of 23 degrees. And 4x minus 5 turns into 4 times 7 minus 5, which very predictably 23 degrees. All right, last algebra geometry relationship of your review. Okay. No, something went wrong here. We have more angles than we actually have anticipated. But I think we could probably figure this one out. We still do have a vertical set with the blue, because we still have the intersection, shared vertices in the middle, x's on both sides. And so I know for at least the first relationship, we're dealing with vertical angles. Okay, so equation should still be 7x minus 2 is equal to 11x minus 34. And you may be asking, what about the y value? Let's ignore that for now. Let's just solve what we have in front of us, like we've done up to this point. All right, in terms of solving, subtract x, or 7x, excuse me, on both sides. Okay, so it leaves a minus 2. 11x's take away 7x's, leaves even 4x's. Minus 34 comes down. Okay, add 34 on both sides. And we'll end up with 32 the same as 4x's. Divide by 4. So x is going to be equal to 8. Okay? So we have x equal to 8. I know we still have that y we have to figure out, but like that doesn't stop us from doing step 3, which is substituting and solving, right? And so we have 7 times x minus 2, that's 7 times 8, because we know what x is now, minus 2, that gives me 54 degrees. I'm actually going to write it up here in the angle area. I think it's going to help us figure out that next step. So 11 times 8 minus 34, also 54 degrees. Okay. So how about this y business? Well, we have to figure out the relationship. I mean, it doesn't actually change our approach, it just means we have an extra step. But what I can notice, if I take this 18 times y angle and combine it really with either side, I'm just going to go to the right here. What we have is one full line. Okay, and so if we have a line, that means if we restart kind of the problem, we have linear pairs, which we know are supplementary. Okay, and by rule, linear pair supplementary, here we go, have to add to 180 degrees. That's what the definition of supplementary is. And so we have 18y plus, I'm going to write this in a different color to kind of make this more obvious. 11x plus 34 is equal to 180 degrees. Okay, so you may be looking at this and saying, well, now there's an x and a y in it. Like that makes it more complicated. But we know what the x value is. We just figured that out. In fact, we know what the angle value is once we substitute it. And so really we can represent this as 18y plus 54. That's what the angle next to it would be. Now that we have our x value, it's the same as 180. And that's the equation we really want to solve. And we're going to kind of like jam in here at the very end. So let's subtract 54 on both sides. So 180 minus 54. 54, here we go. Leaves us with 18 y's, the same as 126. Divide that by 18. And I can't show this step because I'm definitely out of room here. We have the y value to be 7. And you can confirm that by dividing both sides. Now, we know the y value is 7, we still got to find the angle up there. And so if we take 18y, 18 times y, is now going to be 18 times 7, we have 126 degrees. Okay? Which if we can confirm, if we add 54 to that, boom, we get 180, and we are good to go. All right. So the next part up is going to be constructions, right? So that's the thing that I know you guys have been trying to practice in class the most, simply because we have had less like C time for that. But we're going to go through all those constructions here in a moment. And so I encourage you to watch in the event that you have a compass and straight edge available to you. You're welcome to practice as well. But we'll see you in the next video.